All right, so let's begin by doing this exit card question. So we have a circuit, it's got a whole bunch of things going on in there, and it's asking us to find these voltages and that current. So let's just start off by looking at the current. So I'll just pull out a red marker. So we're going to be looking for current first. And we can see that all we're given is this current, I1. So that's the current in the circuit initially. And then you can see that the circuit splits up into two parts. And so we have a current on the left branch and a current on the right branch. So to do this part, what we need to remember is that with Kirchhoff's laws, if you have a circuit that splits into branches, the current within those branches will equal what the original current was. So what I mean is the original current was I1, and then it splits apart into those two branches or those two pathways. Those two pathways, in the case of a current, they will add up to that. And our analogy that we'd used was if we think of it as a river, as the river splits apart into two separate flows, the speed of the river of those two flows adds up to the speed of the original river flow. All right. And so what that means is, I don't know if I've given myself enough space here, 12 amps, that's our original current. We know that I2 plus the 8 amps have to add to it. And so if we do some quick algebra, I'm just going to move this up here because I did not space this well. I2 is going to equal to 4 amps. And that way 4 plus 8 amps in those two pathways will equal the 12 amps we had originally. All right, and so let's put that down here. So we're done with the current. We can erase that now. So I'll just erase that, get that out of the way. We don't need that anymore. Now let's focus on the voltage. So the voltage, we have a couple of unknown voltages that we're going to look for. But what we know is we start with 50 volts. And then what happens is as we follow along the circuit, let's pretend we're an electron, we go from the negative end, we just follow along, and whenever we meet a resistor or any sort of load, a load is a device that uses up the voltage, we'll have a drop in the volts. And then here we have a choice, left or right. I'm just going to go left. And you go back to the battery. So let's say that's the path of a particular electron. And so what happens is, as you follow that path for the electron, it starts with 50 volts, and then all of those volts will get used up as it goes across different loads and returns back to the battery. So what we can say here in this one path that I went through, you can see that we started with 50, we used up some volts, we don't know how much. Then at V2 we used up some more, and we don't know how much. So we can't actually calculate anything, but what we could do is, let's say, what if we had gone, let's retrace this path. What if we'd gone to the right instead of to the left there? If we go down here, and we go back. So in this case, what we have is we have the 50 volts that we're starting with. And what we know is the drop in voltages, or where it's using voltages, like at V1 and V3, those two are going to equal that 50 volts. So what we have is V1 plus V3 is equal to 50. And the nice thing is, by choosing the path to the right, we know what V3 is in this case. and it's just 15 volts. And that leaves us with one thing left to solve, which means we can do some fun algebra and solve for 35 volts. All right, so V1 goes up there, 35 volts. V2, now how are we going to solve that? We could go through another process like this. Now that we have V1, you could, let's say, trace the path of the electron going to the left again, this time like we did originally. This time we have information about the voltage before, so you could solve it out that way, but we're going to do this a different way. So the other piece of information we can use is the fact that these two resistors are parallel to each other in this particular circuit. And so what that means is they're both going to have basically the same voltage drop we can think of. And so we can use that to figure that out. And that's part of Kirchhoff's law. So Kirchhoff's law says that if you have a parallel circuit, the voltages are the same across each of the pathways. So it's sort of the opposite to what we did with current, whereas with current, we said that the current divides itself among those pathways, voltages stay the same across the pathways. So in this case, we have 15 on the right, so we have 15 on the left, so 15 volts. All right, and that's how you could go through that question.